All right, we are going to go ahead and get started. I'd like to thank you everyone who joined us today. Welcome to today's CNCF webinar, Multi-tenancy webinar, Bear Was Make Bear Tenants. I'm Paulo Simões, CNCF Ambassador and Solution Engineer at Hierarchical. I will be moderating today's webinar. We would like to welcome our presenter today, Adrian Ludwin, Senior Software Engineer at Google. A few housekeeping items before we get started. During the webinar, we are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there, and we will get as many as we can at the end. This is an official webinar of the CNCF as a is subject of the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of the Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and the slides will be posted later today to the CNCF webinar page at cncf.io/webinars. With that, you all hand it over to Adrian to kick off of today's presentation. Good presentation, Adrian.
Thanks, Paulo. And I just wanted to say to everybody joining, I know there's a lot going on in the world right now between COVID and racial discrimination and economic uncertainty, and I hope you're all doing well. And thanks for joining me anyway, and I hope that this presentation is worth your while. So my name, as Paulo said, is Adrian. I'm a senior software engineer at Google, and I work specifically on multi-tenancy on the Google Kubernetes engine. Today I'll be talking, despite all of the Google logos on that slide, I'll be talking mainly about Kubernetes in general. I will be illustrating some of the concepts that we're going to be talking about with Google specific products. But a lot of these things, even when I mention one of those, should be applicable to you if you're using Kubernetes, no matter where you're using it. And what I'll be discussing today is really a collection of the best practices that we've either learned ourselves running Kubernetes or Kubernetes-like systems like Borg, which was the predecessor to Kubernetes, and also from our customers. And so if you were at KubeCon in San Diego, for example, last November, you may have seen some of these slides might look vaguely familiar because a lot of our customers were there, and we have taken and tried to collect a lot of the lessons that we've learned from them. And I'm hoping that this will be useful to some of you as well. So here's the topics we're going to cover today. First of all, we're going to talk about why you should use multi-tenancy as opposed to, for example, just giving every team their own cluster, which is often a good, seems like an obvious place to start. And in all honesty, is not a terrible place to start. But you will run into problems. And when you run into the problems, that's when some of these topics will come in useful. Then we'll talk about the principles of multi-tenancy, and then get into some of the sort of concrete ways you can, the tools that you can use to implement it. This will make up the bulk of the presentation. There's a fair bit of material in there, and I'm not expecting everybody, unless you're taking notes, to remember everything that's in there, but it's really supposed to give you an idea of the kinds of tools that are available to you if and when you need them. We'll have a note about some advanced topics, and then we'll wrap things up. And we will try to leave about 10 to 15 minutes for questions at the end. By the way, if you have a quick question, like a request for a clarification for anything you see on screen, please add it to the Q&A. I might not see it because I can only see my slides right now, but Paulo will see it and can interject. But if you have any questions about topics that I'm not covering, I'm happy to answer them, but please leave that until the end. So let's talk about multi-tenancy first. Why use it in the first place? Well, multi-tenancy comes in because as a company, you probably have a couple of key concerns, but a lot of them can be sort of reduced down into cost, primarily cost of your infrastructure, and velocity, which is how quickly your teams can move. And multi-tenancy can have a big impact on both of these. So if you look at Kubernetes at a high level, it looks something like this. You have a user, well, usually several users, who talk to a control plane using the command line interface like kubectl or the API or some UI. And then the control plane distributes work to the kubelets, which are running on the nodes. And so the most obvious way that you can use this is that one tenant will use one cluster. Now, a tenant is not usually a user. A tenant, in the context of this presentation, let's think of it as a team, usually like a dev team that runs a couple of services. There are many other definitions of tenants and tenancy, and we'll discuss those a little bit at the end. But that's kind of the sort of mental model that we're going to use for this presentation. Now, that works great if you are just a small company and you just have a small number of teams, because you can just, well, a second team needs to spin up and you spin up a second cluster for them. But this pretty quickly starts to run out of steam, because as you get a lot of different tenants, you will get a lot of different clusters. And not only that, each tenant might have to manage multiple clusters, especially if you are, for example, running in different regions or different environments, such as dev, staging, or prod. So the first problem you're going to run into is the velocity problem, which is that every team, every tenant needs to become an expert in running, either needs to become an expert in running Kubernetes clusters, which they probably don't want to do, or your central platform team is going to have to become an expert at managing large numbers of clusters, each of which can often be a little bit different, especially if they are not created in a uniform way. The other problem, so this is the velocity side of multi-tenancy. And then on the cost side, all of those clusters might have different usage patterns. Some tenants might be running batch jobs that could be running at night. Other teams might have higher priority or lower priority jobs, or they might be scaling for their peaks. But because they're on separate tenants, they're on separate clusters, sorry, there is no way for them to share resources. And so we've seen customers who have some teams that have a 5-node cluster because they need it for a certain amount of redundancy or peak usage, but on average are using only a fraction of one node. And so this is fine when you're starting up. And I don't want to make it sound like this is that single tenancy is a bad thing. It can be a very good way to start up, but you will start to hit the limitations of that, both from a cost and a velocity perspective, relatively quickly if you start to grow beyond a certain size. So the alternative to this is that you have multiple tenants all sharing one cluster, and you use this concept of a namespace to divide that cluster up among those different tenants. And you'll be hearing a lot more about namespaces throughout the rest of this presentation. Now, to sort of continue on the sort of mental model, this is usually how we think about the combination of clusters and teams. If you think about your different teams sort of as the columns sort of laid across vertically here, you can see that they are separated from each other using namespaces, but they will all share two things. They'll share the raw clusters. And as I said, there could be more than one of them because you could be in different regions and have different environments. But they will all share the same number of, a relatively small number of clusters. And they will also share what I'm calling the production readiness tooling. And those are provided by the platform team or the shared platform. So production readiness tooling can be things like webhooks, operators, things like Prometheus, any kind of low-level piece of software that needs to be running on all of the clusters. This is another factor, of course, in cost. If every team has their own cluster, you'll be running hundreds of different copies of these tools. But with shared clusters, you can amortize the cost of those across all of the different teams. Now, before I talk about when you shouldn't use multiple clusters, I'm going to talk about even in a context of using multi-tenancy when you should. So I've already alluded to the first one, which is regionalization. Most Kubernetes clusters don't work well across the globe. Usually they're a zonal or a regional construct. And so if you want to run in multiple regions, well, then you're going to have multiple clusters, even if each one of those is multi-tenant. Another absolutely critical component is the blast radius. And this is reducing blast radius. Every cluster is a failure domain. If you misconfigure something, a webhook, some permissions, one of those common pieces of production tooling, everything on that cluster can go down. And because we're all humans, if it can go down, it most likely will. And so you need to think about that as you're setting up your clusters. At a bare minimum, you will probably want to separate your environments. You'll want to run things in dev before you run them in prod, possibly staging as well. Sometimes you even have more environments than that. Usually in prod, you'll want a canary cluster because you'll want to serve a tiny bit of traffic, even in prod, from a smaller percentage. And so you might want a minimum of 2 clusters in prod per region. And there could be other reasons why you want to minimize your blast radius as well. For example, if you can't afford to have even one region go down fully. This is going to depend a lot on your own needs. And this will be a refrain that you hear from me frequently, is that you do have to think about your own needs, but these are the kinds of things you should be thinking about. Scalability. This is not something that most people are probably going to run into, especially not at first, but Kubernetes does not scale infinitely. The control plane does have limits. We usually think of those as, off the top of my head, I think it's about 5,000 nodes and perhaps, I forget the exact number, but it's maybe about 100,000 pods or so, or perhaps that's containers. There are limits, but there are many other limits as well, and there are presentations that you can watch about scalability in Kubernetes, which I'll attach to this, this presentation before we share the slides. If you hit one of these problems, you might just need multiple clusters, even if for no other reason. And then finally, there are all of the problems which are just going to drive you crazy for various reasons. Not everything in a Kubernetes cluster can be put into a namespace, things like CRDs, webhooks, cluster scoped operators. Sometimes maybe your organization has had an acquisition and you have a different department that has a different history of doing things, and you just haven't had the time to make those uniform yet. There will be a variety of reasons why you can't always make everything uniform, and that's okay. Even at Google, where most of our systems internally are on one shared platform, there are still some special cases where things have to be segregated for various reasons. So the point of that being, don't worry too much about getting 100% of your clusters into the shared platform. Sometimes it's not worth the effort, or it's not worth the effort today. Now, with that said, let's go into the scenario where you do want to implement multi-tenancy on a cluster. So multi-tenancy is really about different units of isolation. And so let's talk about that, starting not from the top one, but let's start on the second one on this list, which is the cluster. The cluster is the strongest level of isolation within Kubernetes. 2 different clusters will not share nodes, which generally means that none of their workloads can run on the same computer, or at least not on the same virtual machine. They won't share the API server or any part of the control plane. They won't share secrets, they won't share networking. And so it's a really strong level of isolation, both for your control plane and your data plane within the cluster. Now, above that, you have something that is obviously not Kubernetes specific. So in Google, you will have a GCP project. In other platforms, you will have similar constructs. And those are useful to guard access to the clusters themselves. So for example, in GCP, if you don't have access to a project, you cannot list the clusters, you cannot get credentials to a cluster, you cannot interact with the cluster in any way at all unless somebody gives you those credentials through a side channel. And so that's the strongest level of isolation, but that's going to be very specific to the platform you're on. Now within a cluster, you've got a couple of things that start to overlap a little bit. You've got namespaces, which I'll talk about more, and that is a unit of control plane isolation. It is not a unit for data plane isolation. And we'll talk more about that in a bit. You've got the pod, which most of you will know. That really doesn't have any isolation at all. It kind of behaves like localhost. It sort of behaves a little bit like it's running on, like it's a little VM. And we'll talk about ways where you can add things like data plane isolation to it. But your default mental model of a pod is that it's there for your convenience. It's not there for your security. And then you've got the nodes themselves. People often think of nodes as though they are some kind of boundary. They are good for resource isolation. So for example, if you have multiple pods on the same node, you can have a noisy neighbor effect where one of them is trying to hog things like RAM or CPU or network. And in many cases, there are things you can do to mitigate this, but in other cases, the features aren't that capable yet. But they are not good for security isolation, not by default anyway. And there's a great KubeCon talk about this from last November called, I believe, Walls Within Walls, which talks about how workloads on one node can attack workloads on another node. This is improving all the time, but nodes are not considered a security boundary for now. So with that in mind, let's try to get a precise definition of what multi-tenancy means. It means that we are going to provide isolation for security and also resources, as well as fair resource sharing between multiple users and their workloads within a single cluster. I'll talk a little bit, as I said, we've covered the multi-cluster aspect, so now we're really going to narrow down our focus to within a single cluster. And for the most of the rest of this presentation, you can think about this all as occurring within one cluster. Now, how do you apply those principles? Well, the best practices are as follows. The first one is to understand what you need. It's going to be very rare that everybody will need everything at once. You will not need on day one to go through this presentation or any other presentation and say, I need to do everything on that list. We have, Google has a best practices guide, which I'll mention again at the end of this meeting. It's quite long. You do not need to do all of that. You should really be focused on what your risk tolerance is. If one tenant accidentally goes crazy and starts causing problems for another tenant, what's the impact of that? It could be that you decide the risk of that is low enough and the impact of that is low enough that you will solve that problem in 6 months or in a year. Conversely, you might say, well, I'm dealing with very sensitive user data, and it is absolutely critical that nobody who is not authorized to interact with these workloads can interact with this with my workloads in any way at all. And in that case, you're going to go make a different set of decisions. So there is no one size fits all for multi-tenancy. It will depend on your needs, where you are in your Kubernetes journey. Which leads me to point number 2. All of these approaches that I'm going to discuss, they all have benefits and they all have costs. And they all have strengths and weaknesses. And so it's important that while I'm going to mention a lot of them today and maybe give a brief overview of what those are, you will have to look at them, into them a little bit yourself before making a decision. And then finally, as you deploy your solutions, it is best to deploy them iteratively. Make sure that you check in from time to time to see if any of the guidance has changed. Keep them up to date. Make sure that you're on a recent version of Kubernetes in case any vulnerabilities are found, and iterate to achieve more and more benefits. Again, if you try to do all of this on day one, you're going to be in for a rough ride. Sometimes that's necessary, but sometimes it's not. And an iterative approach might work better for you. So with that, let's get into the heart of this presentation, which is how do I actually do this? Now, pretty much everything I'm going to talk about is, for the rest of this presentation, is based around the concept of namespaces. Now, if you don't know, I'm going to assume that most people have at least a basic idea of what a namespace is in Kubernetes, but it's the primary unit of tenancy. It's think of it as on a file system, it's like a folder, but only a single level of folder. You can't have namespaces inside of other namespaces. And so it's although we'll come back to that in a second. So it's the primary unit of tenancy in Kubernetes. Now, by themselves, they don't do much. And the idea of walls in an apartment building are actually a pretty good one here, because you can actually make a hole through a wall and connect 2 apartments if you want to. Lots of hotels do that. You can also put up dividers within one apartment and get some kind of division like that. So the walls are not really kind of magical or special in any way, but what they are is they are a solid boundary between yourself and your other tenants. They work well by default. Pretty much all of the security features and isolation features that I'm going to discuss support namespaces as a first-class attachment point. So while in some cases you can attach to things that are smaller than a namespace or larger than a namespace, if you stick with namespaces, things will usually work pretty well for you. And that's why it's so critical to talk about them. They do also provide isolation in naming. So in Kubernetes, if you have a deployment, for example, in 2 different namespaces, they can share the same name, whereas if you're within one namespace, all of the names have to be unique. But other than that, they're really, for the purpose of this presentation, you should be thinking about them as a means of providing isolation. And how this is going to work is basically each team will get one namespace or sometimes more namespaces, and will put all of their workloads into that. And if you have multiple clusters, for example, dev, staging, and prod, one team will own the same namespace in all of those different clusters. And we actually recommend, this is a best practice, that if you give a namespace to a team in one cluster, you give the same namespace with the same name to the same team in all of your clusters. That is emerging now as a recommendation in the multi-cluster SIG, to the best of my knowledge. And it's a recommended best practice for everybody. And there will probably be some tooling that's developed around this in the open source community and by the vendors if there isn't already. Now, I'll mention a couple of properties of namespaces because there are some downsides to them. They do require cluster level permissions to create. Now, generally speaking, if you have shared clusters, you want a very small number of people to be able to have any kind of cluster level permissions at all. And so that can reduce their effectiveness because only a small number of people can create these very useful units of tenancy. Their policies are fully independent. And usually this is good. Usually you want all of your policies to be, you want different namespaces to have different policies because different tenants can have different needs. But sometimes that's actually a downside. Sometimes you want a lot of your tenants to all be governed by the same set of rules. If you want to use them manually for policy application, so for example, network policies can control traffic from one namespace to another, you have to label them manually. And because labeling is not considered to be a separate operation from any other kind of updating operation, what that means is that anybody who can edit a namespace in any way can change labels. And that means that labels are not really ideal as a security mechanism. But they are included in Kubernetes natively, no matter which version of Kubernetes you have. I think all the way back to, well, before 1.0, although that's before my time, you've got namespaces. Now, I am personally working on a project as part of the open source community that tries to address some of the issues that you can have with this, and these are called hierarchical namespaces. So this is a call out to some of the work that I'm doing as part of the multi-tenancy working group. Hierarchical namespaces are regular Kubernetes namespaces, but with a couple of additional properties. They allow you to assign each namespace an owner, which is another namespace. And you can have any number of roots. So in this diagram here, you have 3 roots, org 1, org 2, and then down below the Snowflake team that isn't part of any organization. And then you can have a namespace per team, and then teams can own multiple namespaces. So if you're interested in this project, please go look for the hierarchical namespace controller. This is not a new feature that's inside core Kubernetes. It is an open source controller that you have to install yourself. But this project is just getting going now, and it is useful if you want to, for example, inherit policies from your ancestors. So the most useful thing about hierarchical namespaces is that you don't need that cluster level permission anymore. There is a way that if you have a sub namespace creation permission at a namespace, you can create another namespace underneath that. That namespace will inherit the policies from its ancestors. And so you don't have to worry about this new namespace being a free-for-all. HNC also sets up all of the labels for you and doesn't allow anybody to edit them. So you actually can rely on the labels created by HNC for use in your security story and for your policies. And as I said, these are provided by an OSS project called HNC. Or if you use GKE, we've got a new feature called the hierarchy controller, which is based on HNC. That's coming out in the next couple of days. It's not actually available today, but it will be available, I believe, by the end of this week. And that's just an alternative way of installing HNC, plus a couple of other things that we'll be adding in the future. Now, so that was an overview of the namespaces. Now let's talk about what you can do inside of those namespaces. And so they really fall into 4 categories: access control, resource sharing, runtime isolation, and insights. I can think of that as things like logging and monitoring. So let's start with access control. Tenancy is really about ownership. If anybody can walk into your apartment, you don't really own it in some way. It makes sense to have a door that you can lock. And so job number 1 is making sure that tenants can't control each other's resources. The primary way that we do this is through a process called authentication and authorization. So authentication is how does Kubernetes know who you are? And authorization says, what are you allowed to do inside Kubernetes? So if you are talking to the control plane will have 2 ways of answering these 2 questions. First of all, authentication and authorization can be pluggable. So for example, if you are on GKE, it integrates with Cloud IAM, and different vendors will of course integrate with their own identity systems. And those can also be used for authorization as well. Sometimes if an external, or sorry, in all cases, if an external authentication and authorization provider says you're allowed to use something in Kubernetes, the control plane will let you use it. If it doesn't, you fall back to RBAC, which we're going to talk about it in a second. And RBAC is the recommended way to do authorization in Kubernetes, and it is a part of OSS Kubernetes. RBAC stands for Role-Based Access Control, and it controls access, I'm going to say, to namespaces in Kubernetes. You can actually use it in some cases to control things that are not in namespaces, but for the purpose of multi-tenancy, this is the best way to do it. So they're used to give humans access to Kubernetes resources. And on GKE, you can also use things like Google Groups to give groups of people identical access. They can be used to give service accounts or robot accounts access to the Kubernetes API. So for example, on Google, you can use a GCP service account. And so both humans and other services that are not running in Kubernetes can be used to have access to the Kubernetes API. And they can also be used to give access to pods that are running in the cluster, access to the Kubernetes API using Kubernetes service accounts. Again, these are built into Kubernetes. There are basically two key concepts that you need to understand for RBAC. They are the concept of role, which means this is a set of things that one is allowed to do, and the concept of a role binding, which is to say who is allowed to use this role. One user can have multiple roles. Roles can be bound to multiple users. And they're both cluster level roles and role bindings and namespace level roles and roles bindings. For multi-tenancy, of course, we recommend that you base this all on namespaces. And if you're using hierarchical namespaces, any role or role binding that you create in an ancestor namespace will automatically be propagated to all of the descendants. It's important to note that you can differentiate access within a namespace to different types of resources for different people. So within one team, you can have a team admin and you can have a regular team member, and they can have different access within that namespace. But if you use role bindings for both of those, you'll be guaranteed that neither of those accesses can ever bleed outside of that namespace, or a tree of namespaces if you're using HNC. Now, workload identity is a way to sort of run that whole process in reverse. Everything I said before is about accessing the Kubernetes API, but what happens if you have a workload that's running in Kubernetes that needs to access something outside of the cluster? Now, your workload in Kubernetes, its only identity is the Kubernetes service account, or the Kubernetes SA, as I call it here. And what you would usually do is that if you need to access some other system, you would create credentials in some form, a password or a long-lived token, or maybe a private key. You would encode that as a secret and make it available to that pod's service account. If you're using GKE, there is this alternative called workload identity, which allows you to map a Google service account to a Kubernetes service account. And what that means is that any workload that runs on Kubernetes under that service account can automatically access those resources in a GCP project or any other kind of Google resource. Let's move on now to resource sharing. So even though you have this concept of namespace, namespaces are a control plane construct. But there are lots of things that are not part of the control plane that needs to be shared, including the API server itself. And so it's important that your different tenants can cooperate with one another and not take up too much of their fair share. So there's a couple of constructs here. I'm going to go through them quickly. The most obvious one is quotas, which basically allows you to say things like no one namespace can exceed this amount of resource usage. No one namespace can use too many CPUs or too much RAM or too many GPUs. And you can also use it to control dangerous objects. So for example, you can say these namespaces are not allowed to create any ingress objects or load balance services at all to forbid them from being open to the outside world. You can say somebody's not allowed to create more than 10 secrets because you think that that might be a sign that something has gone wrong in their security story. Limit ranges are very similar to quotas in a way, but what they say is that no one pod in that namespace can exceed a resource usage. And so it's quotas are aggregate, limit ranges are basically they prevent you from, tenants from doing things like saying, well, I want to use a 96 core machine for every one of my pods, and thereby essentially evict everybody else from those nodes. You can use pod affinity and anti-affinity to keep pods scheduled on the same node or on different nodes, and sometimes within the same zones or different zones. There's a wide variety of things you can do to control the scheduler, and affinity and anti-affinity are the most important ones. There are other things like taints and tolerations. If you are interested in those, you can look up the scheduler documentation. And then when all else fails, there's priority. If there isn't enough to go around, pod priority will allow higher priority pods to evict lower priority pods. This could be useful if you have batch workloads that are not time critical, or if you have, for example, a lower priority service, let's say a recommendation engine that is nice to have but is not critical. And if your checkout system is overloaded, it can evict those other less essential services that can degrade gracefully. So these are the fundamental, probably the most important constructs that you can use for resource sharing. Again, there's no need to necessarily set up all of these on day one. We have some customers who have been running multi-tenant clusters for a year who don't yet use resource quotas because it has never arisen for them. It's never been an issue. We have others who were concerned about that from day one, and so they implemented them right away and then fine-tuned them over time. That's fine too. It will really depend on your own needs. Let's talk now a little bit about isolation. So runtime isolation is really about keeping things in the containers like they're supposed to be. So vulnerabilities and attacks do happen, and containers are not a security boundaries, which means that pods are not a security boundary, which means that if you are, for example, running some component that you didn't write yourself and it has a vulnerability which can be exploited, there's a chance that somebody could break out of that pod and attack other things on the same node, or even if they get access to the API server, they could attack other workloads on the same cluster, even if they're not on the same nodes. And so you should think about adding runtime isolation to try to prevent this from happening, keep everything in their cages. Yeah, this just illustrates, to refer back to that earlier diagram that I showed, we're really talking now at the pod level. There is no isolation at the container level by definition. And so all of the isolation that we're talking about now, the runtime isolation, is really focused around the concept of the pod, not the namespace or the node. Although these policies can be applied at the namespace level. Now, what are the constructs for this? Well, the most important one is the pod security context. So for example, when you're creating a pod or a deployment or anything that can create a pod, you can restrict what that pod's workload does. So for example, you can say that the workload that is started by this pod must not run as root, or that it only has access to, I believe, certain ports. To be honest, I forget all of the things that pod security context can do, but there is a large number of things that you should go look through and say, well, if I don't trust the workload that I'm running, maybe I should restrict it to make sure that if there is a vulnerability, there's a limit to what the damage can do. Pod security policies are a way to enforce that across your entire cluster. So what they do is they enforce that a pod must declare an appropriate context. So pod security policy is when you don't trust the author of the security context. The security context is when you don't trust the author of the workload. So that's kind of how they scale. Now, unlike just about everything else in this presentation, pod security policies are actually quite hard to enable incrementally. So either you should actually consider whether you need these from day one for a variety of reasons, which I won't get into now. If you don't want to use them, if you're thinking of doing something incremental, you should consider an alternative like Gatekeeper, which allows you to write these similar kinds of rules, but for any object, not just pods, and also allows you to introduce them incrementally. Anthos Policy Controller, if you're in the Google ecosystem, is an extension of Gatekeeper, but Gatekeeper itself is open source and it's easy to look up. Network policy is a way to forbid pods from talking to each other if they have no good reason to. So there's no good reason, for example, that your recommendation engine should be talking to the credit card processing component service. And so it's probably a good idea to put something in place to make sure that those can't communicate at any level. Network policy works on the L4 level, which is TCP level. If you are using Istio, you can also implement different policies at the L7 level. But network policy is really like the kind of bare bones. And then finally, if you are worried about people breaking out of containers, despite all of the other things that you have been you've put in place, you can set the runtime class. By default, the runtime class uses runc, which is the, I believe, or containerd. I always get those two mixed up, but basically Docker. But there are alternatives such as gvisor or kata containers. So gvisor is an open source tool which basically runs your pod in a sandbox, and even if it breaks out, it is considered to be a security boundary, unlike a regular container. And the same is true for kata containers. If you are on GKE, this is very easy. You can set your runtime class to the GKE sandbox, which is based on gvisor, and it allows you to, without any application changes, basically make sure that you run securely in a sandbox. And this is based on technology that's been used to run Google App Engine in prod for many years now. Finally, I'll talk briefly about insights. And so this is how you monitor your tenants, how you make sure that they are behaving themselves, and how you allow them to monitor themselves. It's important to be able, it's important for tenants to be able to observe themselves. Otherwise, that falls to the central platform team, which is going to be overloaded. And it's important for that platform team to be able to understand the resource usage of each tenant, either just to make sure that nobody's using something unfairly, or in larger organizations that tenants' business unit might need to be charged back for the resources they consume. So usage metering is a feature of GKE where you can look at everything that's in a namespace and break it down by memory, CPU, GPU, etc. And then you can export that to BigQuery, join it to the data in GCP billing, and use it to figure out how much each tenant is actually consuming in terms of dollars. I should, before I go on, I should add that most of this is not actually built into Kubernetes, so I'll be using Google-specific examples, but there are many alternatives, both open source and vendor-specific for these. So just think of this more as an illustration of the kinds of things that are available to you. This is an example of what usage metering looks like in the UI. Then there's multi-tenant logging. So logs are quite sensitive because logs can in turn can include user data. They can include all kinds of details about the operation of your workloads that you might not necessarily want to share widely between your different tenants. So you need to control access to them very carefully. So the best way to do this on GKE is that you create a tenant project for each of your tenants. So this is a GCP project, and give each of them a BigQuery data set. And then you can use Stackdriver log routing to make sure to look at all of the logs that are coming out, and then based on their namespace, route them to those different projects. And this will ensure that, that every team, every tenant only has access to their own logs, but nobody else's. There are actually some improvements coming here that are a little bit less heavyweight than creating entire new projects for every tenant. But in general, having some kind of external construct like a tenant project is not a bad idea. In this specific case, there are some improvements coming over the next couple of weeks, which you can look up later. Now, monitoring, which is to say metrics, are generally a lot less sensitive. Usually they don't include nearly as much information, and a lot of our customers don't actually differentiate access by tenant. Generally speaking, every tenant can see the metrics coming from every other tenant. It's just not worth it to people to go to the trouble of routing them in different directions. However, with that said, if you do need to control access, there are ways to do that. So for example, you can create a Prometheus, you can install Prometheus into your cluster, and you can use the Stackdriver adapter to say that all of the metrics that come from a certain namespace get routed again to the correct tenant project. So it's not built into Stackdriver, unlike logs routing, because as we said, we see a lot less demand for this, but it's something that you can consider if it works for you.
Adrian,
yeah.
Just two questions about logging, right? Really, two questions. One question is about multi-tenancy, and the other about logging. Just start with logging. That was the last topic. The question is, can you also tag / label log streams to easily identify them in GCP?
Yes, you can. And if my memory is correct, any label that you put on the pod will be available to the log router. And so, which means that if you put a label, for example, on the pod spec for the deployment, you will be able to filter based on that. So namespaces are the default way. Namespaces are always available, but if you want to add additional tags, you can do that through Kubernetes labels. Now, you have all of the problems that I mentioned about labels earlier, which is that anybody who can edit the object can also change the labels. And it can be easy to forget to add a label unless you use a webhook to ensure that or something like that. But yes, you absolutely can do that. Does that answer the question?
Okay, the other both, there's more too, but I will do that in the final, right? Mm-hmm. In the end of your presentation.
Yeah, I can see. Okay, I'm just looking at the other questions. We'll come back to those in a few minutes. So I'll just finish up very quickly with a couple of advanced topics. Mostly I've been talking about in-cluster multi-tenancy, but it's usually a good idea to think about storing your source of truth somewhere else, just in case, well, for starters, you might have multiple clusters and you want to keep them all in sync, or you could lose a cluster and need to replace it with another cluster. So it's a good idea is to check all of these policies into Git or some other source control system, and then either have your cluster admin apply them based on the latest Git or some branch on Git, or use some kind of continuous delivery tool like config sync or Anthos config management. There are lots of other open source alternatives to this as well. The other recommendation I would give here is that please test out your changes on a canary cluster first, even in prod. Even if it's gone through dev and staging and everything's worked fine, there's always the chance that when you put it in your prod environment, you've gotten the name of some service account wrong and everything goes down. So it's always a good idea, especially with these very sensitive objects, test them out on a canary cluster first so that if something goes wrong, you only impact 1% of your traffic or 0.1% of your users. And finally, if you are using GitOps, we would recommend that you separate your policies from your workloads because they really do operate at different levels. A possible exception to this might be daemon sets, which are kind of straddling the line between policies and workloads. If you want to enforce that policies are being applied evenly, I'd recommend using Gatekeeper or Policy Controller to define and apply custom policies. What you do here is you define rules in Rego, which is a Python-like rule language. You can apply them across your clusters. If there are existing objects that violate them, they won't suddenly stop working. They will just show up as a violation, violation in your audit. And they're a good alternative to pod security policies. There's a lot of work going on Gatekeeper right now from, I believe, Styra is the company that's leading the effort. I know that Microsoft is heavily involved as well as some of my colleagues at Google. And it's a great project and I encourage you to check it out. And finally, I will just briefly touch on two topics that I haven't really spoken about, which are, they're both subcategories of what we call hard multi-tenancy. In the mental model that I've outlined up until now, I've been encouraging you to think of tenants as teams within an organization, which is to say, you can assume a certain amount of trust between them. People might make mistakes. Every now and then you might have an employee that does something they shouldn't, but they're not usually actively malicious. Hard multi-tenancy is a concept where you have to assume that your tenants are mutually hostile. And of course, it exists on a spectrum. If you're at a bank, for example, you might have to assume that even your internal tenants are somewhat hostile. There's a couple of ways that you can go about fixing these problems. One of them is called virtual clusters. Like HNC, this is a project in the multi-tenancy working group. It gives each tenant its own control plane while showing the data plane. You have to combine it with sandboxing to make sure that to truly isolate all of your workloads. But that's a good way that's something that you can consider using to truly separate your tenants from one another. SaaS multi-tenancy is a whole different kind of type of multi-tenancy where instead of the tenants being teams, they are instead your customers, but they're all usually running the same kind of thing. Usually you're going to require some kind of sandboxing between them and some kind of control plane automation. So things such as RBAC might become a little bit less important because the tenants don't actually access the Kubernetes API. but things such as resource usage and attribution becomes more important because you need to charge them. So your needs are going to be very specific to your thread model, your usage model, and it's a very big topic, but these are what I've shown in this presentation should be a good place to start. So just in conclusion, make sure you understand your needs. Don't feel like you have to do all of this at once. It looks scary if you look at it as, oh my God, there's 50 slides I need to get to, but that's usually not the case for most people. Look into the technologies yourself, understand the pros and cons, try things out, work iteratively, and make sure that you are making small changes to handle yourself. I will, when these slides get uploaded, I'll make sure that there are some links, not only to our best practices guide, but also to some of the other KubeCon talks that I've referenced in this talk. And that is it. And so I think that with that, we can get to the questions. So why don't I read them out because I can see them here.
Hi, Adrian, amazing presentation. Thank you so much. We have some questions, right? I will ask for you just a minute. If anyone has more questions, please use the Q&A box. We have 5 questions now. Will you consider using node pools per tenant for isolation of viable solution? And is it better to use different clusters at this point?
So it depends what kind of isolation you're looking for. So for example, as I said, node level isolation and node pools in GKE are an extension of nodes. Are very good, can be very useful for resource isolation. So for example, if you've got one workload that has very different characteristics to anybody else, they need different size nodes, they have very high network bandwidth requirements, for example, then it can be useful to put them onto their own node pool. They are not a security boundary, as that KubeCon talk that I mentioned goes into the reasons why, because they all do still share access to the same control plane API. So if you are able, so if a workload is able to break out of the container, even if they can't attack the other workloads directly, the API server has a fairly large attack surface and is not generally considered to be a hard multi-tenancy solution. So it's useful. Now, as for the other side of that, should I just go ahead and use different clusters? Again, that will depend on your needs. If, let's say that one team has some workloads that need that level of isolation, but some that don't, probably more useful to keep them all in the same clusters. Let's say that you've got a team that is, a central platform team that is setting up all of those clusters individually. Again, it might be easier for them to create a node pool than a whole new cluster. If that's not the case, then it might make sense in some cases to create that Snowflake cluster for that purpose.
Okay, thank you. Let's go. Hi, from, well, anonymous, I don't know. Can you also please share any best practice for doing multi-tenancy in the context of supporting multiple customers in the production environment?
So yeah, I kind of touched on that at the end. That's what I called SaaS multi-tenancy. This is where you are providing software as a service to different customers, or at least I believe that's what the question is. Please ping me if I'm wrong. Yeah, many of the same things will apply. As I said, some things will become less important, such as RBAC, because the different tenants are not contacting the API server directly. And so that's one whole class of threat models that you can eliminate. But other things become more important. So runtime isolation, such as using a runtime class, using a GKE sandbox or gvisor or Kata containers, can become more important, especially if you are running, for example, an open source piece of software that was not really designed to work in a multi-tenant environment. So in that case, runtime isolation, using network policies to make sure that they can't snoop on each other's traffic becomes more important. Resource quotas might be important if you have auto-scaling, any kind of auto-scaling turned on. But generally speaking, you will have your own control plane in front of the Kubernetes control plane. And a lot of the threats that are present in a sort of enterprise context can be addressed by your own control plane in that context. So I hope that answers your question. It is an interesting area, but I would say that it's there's a fair amount of overlap, but it's not exactly the same problem. So I hope that that gives you at least some good ideas as to where you can start looking.
Thank you. Moran, could you elaborate more on the hierarchical namespace project's use case and goals? And if you have time, more on the network level traffic isolation between pods belonging to different tenants.
Right, so very briefly, hierarchical namespaces, thanks for that question. So the there's basically two main use cases that it addresses. One of which is delegation of namespace creation. So it allows you to delegate, this is usually a very powerful operation, and there are lots of reasons that you might want an isolation boundary like a namespace, but you don't want to have cluster level permissions, or you don't want to give that person or that robot account cluster level permissions. So it really does allow you to delegate namespace creation while still allowing the policies that a higher level administrator has applied to one namespace to flow down to those other namespaces. And so it was actually based off of some of the lessons that we learned from Anthos config management, which is now also available to all GKE users as config sync. Because we did find that a lot of users did want to use hierarchy as a way of designing their policies in the first place. Not all policies can be applied hierarchically, but when you do want that kind of concept of ownership, hierarchy is by far the best way to do that, because unlike labels, which can be, first of all, the labels are not access controlled themselves. Secondly, you can forget labels, you can make a mistake with labels. With hierarchy, it's usually much clearer. Either a namespace is owned by another namespace or it's not. So I would encourage you, if you have more questions about HNC, to please go look us up on GitHub. We're part of the multi-tenancy working group. There's a user guide, and we're also available on Slack, and there's a bunch of other ways that you can contact us if you're interested in HNC.
Thank you. Another question? We have more 5. Any ideas on whether hierarchical namespace is or will become a first-class abstraction in Kubernetes?
So there was apparently a long debate in the early days of Kubernetes about whether namespaces should be nested or not, and be hierarchical or not. And the answer that they came upon at the time is still true today, which is that at the time there wasn't enough evidence that the additional complexity of hierarchical namespaces or nested namespaces would be worth it. That is still true today. However, there was enough evidence that it would be useful that we embarked on the concept of HNC. What I would say is that if we see a lot of uptake of HNC over the next year or two, that would certainly raise the possibility of making it a first-class construct in Kubernetes, which would have a number of benefits. So for example, all hierarchical namespace names must be unique across a cluster, which is annoying. It's not as bad as you might think. For example, at Google, we have tens of thousands of namespaces in a flat that are visible to everybody and that are flat. It's not the best in the world, but conflicts are actually surprisingly rare. But it would be nice if you could have, if they could be nested in some way. You could also do things like hierarchical watches and lists, which are not possible today. But yeah, I think that what I would say is that if we see good uptake over the next year or so, then you could see that become part of the core offering. Now, what I would emphasize is that it is run under the Kubernetes organization. It's part of Kubernetes SIGs. It's open source, and so you can rely on that. Paulo, there's one question that I'm wondering that if we've overlooked from 1131. Mind if I answer that one next, because they've been waiting a while for their answer? It says, consider the case of two applications handling privacy-sensitive data coming from competing vendors. Would you trust the barriers you have today is good enough to trust running those two applications in the same cluster? They might both store their source of truth externally, but would likely still use Kubernetes for secondary secrets. I think what I would say is that at a runtime level, yes, I would consider things like gvisor to be, or GKE Sandbox to be a sufficient barrier. If you mean using Kubernetes secrets themselves, like Kubernetes has a built-in concept of secrets, If you are saying that you would like to store that information there, then that becomes a little bit more dicey. Secrets are not available outside of their own namespace. But if you're not careful about your RBAC, a workload from one namespace could somehow gain access to secrets in another. So if that's what you're saying, you're going to want to think very carefully about that. But from a runtime level, I would say that yes, with some careful design, that would be that should be possible.
We have, Adrian, we have more 7 questions, but just 2 minutes. I will try to to follow them. You can stay more 5 minutes or 10, I don't know.
I can stay an extra 5 minutes, yeah. So I'm happy
yeah,
to
okay, 5 minutes. Let's try. Can you expand on traffic routing in a multi-tenancy environment?
So I think what I would say is that network policies as a kind of built-in aspect of Kubernetes are the way that you handle, it's not really routing, it's more like lack of routing. Ingresses are also a little bit complicated because ingresses, ingresses are per namespace as well. And so that does allow you, if you trust somebody to create their own Kubernetes ingress, a tenant, I should say, then routing is not really a problem there. And then you use network policies to restrict what you do beyond that. If you're looking for something more robust than that, for example, like a single cluster level ingress with very sophisticated kind of service-to-service authentication, mutual TLS, stuff like that, then you're getting into the territory of Istio. And I'm not an Istio expert, but Istio absolutely has all the constructs that you need to build a very powerful and trustworthy service mesh, where you can be very careful about what gets communicated between different services, how they're encrypted. You can do both service-to-service authentication, also end-user authentication. Istio is an amazing project, and so I don't have time to go into the, I'm not an expert and I don't have time to go into that, but you can check that out.
What do you think, Marwan, what do you think on using kiosk project for multi-tenancy?
So that's kind of funny. I only found out about kiosk a couple of days ago from Carl Eisenberg tweeted about it. And so I went and looked it up. It's similar to some earlier projects that were going on in the multi-tenancy working group. Sorry about that. And so I think what I would say is it's a useful, if it matches your use case perfectly, then it's quite useful. The reason that we've gone with this approach of hierarchical namespaces is because namespaces really are the unit of, there's a couple of reasons. They are the unit of tenancy already. And so extending that as opposed to adding new concepts such as account or tenant or team or something, I forget exactly what it is in kiosk. But instead of adding a new concept, we wanted to add new behaviors to an existing concept. So they can address some of the same issues, but what we think we've done is made something that's maybe a little bit more flexible at the cost of perhaps being less well suited to whatever kiosks use cases are. So as with all things, I would encourage you, if you're considering both of them, to look them up and see what's the best for you. But I have been thinking that I should probably reach out to I don't think I've ever spoken to anybody from the kiosk team. I should invite them to the multi-tenancy working group so we can have a discussion.
Okay. Marwan, have you seen SL Linux used to implement safe multi-tenancy instead of sandboxing?
I am unfortunately not the expert for that. If my memory is correct, pod security policies can be used to enforce SE Linux properties or whatever you call them. I'm not the expert there, but I believe that that is something that people do. I am not personally familiar with it. I don't know if anybody else, any of the other, anyone else on the call wants to chime in, but I believe so. The answer is yes.
Oh, this is big. Most tenants use an image from Docker Hub which use the root user. Do you have any suggestions on best practice to mitigate this vulnerability with minimal impact on the tenant's user experience and container performance?
I am not sure what you mean by the root user. Certainly when you are pulling an image, you can provide secrets to pull that image. Yeah, I'm afraid that I'm not sure about that. You can try to, my email address is aludwin, A-L-U-D-W-I-N @google.com. So you can send that to me and I'll try to route you to somebody who can answer that question. Yeah, sorry about that.
Okay, Adrian, our time is the end. So how do you think that's better to answer the other questions so people can reach you in some place or interact or use any channel? Please, what's the better?
Yeah, so you can find me at aludwin, A-L-U-D-W-I-N @google.com, or you can also ping me on Twitter. I'm available if you look up HNC or the Multi-tenancy working group. I'm a member of that working group, and so that group also might be a good place to send your questions either on Slack or on the mailing list. So yeah, there's a bunch of ways you can reach me or other people who are knowledgeable in this area, because I'm far from the only one or even necessarily the best one.
Okay, thank you, Adrian. Thank you very much. It was an amazing presentation. I learned a lot, and I will ping you for other questions, mine questions too. Everyone, thanks for joining us today. The webinar record and slide will be aligned later today, and we're looking forward to see you at the future CNCF webinar. Have a great day, all.
Okay, thank you, everybody. Have a good day.
Thank you. Bye.
Thank you.